Alright, this is the fourth part of our lesson on graphing rational functions. We are picking up here with number 9. Alright, X-intercepts. How do we find them? We find them by setting the numerator equal to 0. So that's going to be 4 times x plus 1 equals 0. Well, I could just divide both sides by 4 right now. And that would give me x plus 1 equals 0. And then I could subtract 1 from both sides. And that would give me x equals negative 1. And that, my friend, is how you find the x-intercept. Because it is the x-intercept, this is an x value. So I put my negative 1 here. On the y side, of course, it is 0. And go ahead and plot that right now. X-intercept, negative 1 comma 0. Check. You know what? I feel like graphing my zeros in purple. Alright, so I'll know that they're not off my table of values. Anyway, so now the y-intercept. How do I find the y-intercept? Well, for the y-intercept, you substitute 0 for all the x's. So I'd be putting a 0 here, and here, and here. But this is a problem. If I put a 0 here, 0 times anything is going to be 0. Okay, so that's going to give me 4 over 0. But this is undefined. You can't divide by 0. So there will be no y-intercept. No y-intercept. Alright, so probably there's an asymptote there. Alright, so for y-intercept, just put none. Vertical asymptote. How do we find vertical asymptotes? You set the denominator equal to 0. Okay, so that means x times x minus 4 equals 0. Well, this is already factored for us. Very nice of them to factor for us. So I will set these factors equal to 0. X equals 0 and x minus 4 equals 0. So this already gives us one of our vertical asymptotes. But this, once we add 4 to both sides, will give us x equals 4. And that is our other vertical asymptote. So these are the two vertical asymptotes. Alright, so vertical asymptotes, x equals 0 and x equal 4. Alright, horizontal asymptotes. How do we find those? Well, I'm glad you asked that. Remember, horizontal asymptotes, that's a little more complicated. That's where we have to ask ourselves, which one of these three cases are we in? We're talking degree. Alright, is the degree of the numerator less, equal, or greater than the degree of the denominator? Alright, that'll depend. So let's see what we have up here. Well, it's a little bit hard to see what the degree is in this form. Okay, but I'm sort of counting the x's. So see how there's just one x there? That means this is going to be a degree of 1 up there. But see how we have the two x's side by side? That means that's going to be degree 2. Okay? Another way to think about it is do the distributive property. If I do, I'm going to get 4x plus 4. Alright, so clearly that's degree 1. It's a linear. If I do the distributive property down here, I'm going to get x squared minus 4x. And you see there that the degree is 2. Either way you want to look at it. The degree of the numerator is less than the degree of the denominator. Alright, that's the first situation here. And when that happens, we've learned that the horizontal asymptote is simply y equals 0. Okay, so horizontal asymptote, y equals 0. So let's go ahead and graph these three asymptotes now. I'll do it off camera. Alright, notice how we have an X-intercept sitting right on this horizontal asymptote. There was a time that I would have thought that was a problem, but I've since learned that the horizontal asymptote is not a brick wall like these vertical asymptotes are. It's only there guiding the end behavior. So it's okay that the graph is touching the horizontal asymptote. Just watch out for the end behavior. We might want to use extra points around here so we can see what's happening. So stay tuned. Very interesting. Okay, now that we have the asymptotes, it's time to make the table of values. Okay, especially the vertical asymptotes. We want to make sure we have points to the left and right of each asymptote. And I like to use decimals as well. Make sure you use points just to the left and just barely to the right. I'm talking less than 1 away. I'm talking decimals. Okay, so I already have -1, so let's definitely use -2. Let's get that on the list. But like I said, I want decimals to the left and right of every vertical asymptote. So just to the left of this is 0. So just to the left would be -1/2. So let's do that. Just to the right would be +1/2. So let's do that. Okay, 2 is right in the middle, so let's definitely use that. As a matter of fact, you know what, let's do all of these. Let's do 1 and 2 and 3. Let's do all of those. Okay, we definitely had to do the 2. Gotta know what's happening in the middle. But let's also do this decimal just to the left. So let's do this, what's this? This is 2, so this will be 3.5. Okay, just to the left of that asymptote. So 3.5. Okay, so I'm running out of space on my chart, but I don't care. Let's go just to the right of the asymptote. So that would be 4.5. I want that too. Alright, so I hope you're seeing the idea. The more points, the better, guys. Okay, so 4.5. And let's just do one more. Let's go ahead and do 5. Okay, so let's get all of these values. Alright, so I'm going to type this function into my TI-30XS multi-view. See, 4 times x plus 1. Well, let me get over there. So hit your table button. Just get ready a little bit. Alright, so we have 4 times x plus 1. So 4 times the quantity x plus 1. And then x times x minus 4. Alright, so x times x minus 4. Okay, let's definitely use the Ask X feature. We have a lot of decimals and fractions that we're dealing with, so we can just find all of these values using the Ask X feature. So just hit enter, and let's just type in one by one what we want. So for example, -2, so just type in -2. Alright, so that's -1/3. If I want to do -1/2, I'll just type it in. -1/2. So that's 8/9 converted to a decimal with a toggle key. That's 0.9. +1/2. 1/2. Okay, toggle it. That's -3.4. Alright, keep doing that till you get the rest of these values. I'll do the rest off camera. Alright, so these are the values that you get, and these are the points that you plot. Now it's a good thing that we did all those decimals really close to the asymptote, because especially consider this point right here. If we didn't have this point, you might think that it went up. But because we have this point close in, we see that it goes down, which changes the entire nature of the graph, changes the range and everything. Okay, so please follow my advice and use values really close to the asymptote, just on either side, like within less than 1 away. Alright, anyway, this gives me a pretty good idea of what's happening. It's very strange over here. We're crossing over the asymptote. So that happens sometimes. So you can pretty much bet that as this continues on, it's going to go ahead and approach the asymptote from underneath. So this branch is probably going to do something very much like this. Okay, and this is hard to draw, but it's going to be something like this. Alright, so that's what's happening here. Down here I've got this whole loop thing happening. So that's going to go like something like that. Whoa, okay, messed that up a bit. Let's see if I can do any better. Okay, so something like that. And then over here, you can bet that it's going to come down and approach the asymptote. It would be nice to have another point over here. Let's see what's happening at 10. Just go back to our calculator real quick. There's nothing stopping you from trying other points. So let's look at positive 10. Alright, if you're having any doubt what your graph looks like, just use a couple more points. So at 10, we've got 0.7. Okay, so over here at 10, we're at 0.7, which would be right about there. Alright, so indeed, it's doing this type of thing. Okay, so that's what your graph should look like. Alright, just for fun, let's take a peek at the graphing calculator and see how we did. Kabam! Nailed it! Okay, anyway, let's go on and do the rest. So the domain. The domain is, we're going to have to do it in 3 parts. So this left part over here covers the x values from negative infinity to 0. Okay, from negative infinity to 0. And then the middle part covers the x values from 0 to 4. I'm writing really small because then I need room for the third branch, which represents all the x values from 4 to infinity. Alright, obviously not including these asymptotes, which is why we're using parentheses and not brackets. Alright, so 4 to infinity. Okay, now for the range, we're going to have to do a little bit of estimating. Okay? Because we don't know exactly what the highest point is. It's something very close to this point right here. So what is this point? This is the point 1 comma negative 2.7. Okay, so this bottom part, because the range is from bottom to top, right? So this range goes from negative infinity up to whatever this is. And calling it negative 2.7 is pretty close. Okay, so let's just use that. So the range, negative infinity up to here, which is negative 2.7. Alright, now it hits 2.7. There's no asymptote or anything, so I'm going to use the square bracket. And then my goodness, okay, like these points over here, this is below the asymptote. So I'm not going to say 0 to infinity because it goes below, it crosses over this asymptote and then approaches. So whatever, this is like I'm estimating again. This point right here at negative 2, what was that? It was like negative 1/3. Okay, so I'm gonna say negative 1/3 to infinity. Okay, so I'm estimating here. I'm going to be a little off. It might go a little further below. We don't know exactly how low it goes. So on a test, am I going to give you one like this and ask you the domain and range like this? Probably not. With all these subtleties and estimates, we'll give you one that you can just state the domain and range very clearly. Now, you may very well be asked to graph it, so don't think you're not going to see one like this, but just maybe you won't have to do the domain on that one. Okay, so there you go. Now, increasing and decreasing intervals. Now, technically, this dips down a little bit before it goes back up again, but I'm going to ignore that. And just, again, because we're sort of rounding and estimating, it's impossible, for me to nail down, okay, it dips a little, and then how far does it dip, and where does it start going back up? We don't know. But it's a very small dip anyway. So mostly this graph is increasing from negative infinity to 0. All right, just x values, please. So negative infinity to 0. This graph is pretty much increasing. But yes, technically it dips a little bit here, but I'm just going to pretend I didn't notice that. Okay, so from negative infinity to 0, it's pretty much increasing over that interval. You know what? This is silly, because like in here it's increasing and decreasing. Should I estimate again? Yeah, I'll just keep estimating. This whole business right here with the range. I'm gonna highlight this because I'm guessing. And these every time I do an interval, okay, like this increasing interval, that was, I'm fudging that. And so here I'm going to have another increasing interval from like here to here. But I don't know exactly, I have no proof that this is the highest point. It's just one of the points I picked. But just so you can still get the idea, it is increasing from here to here. So that's from 0 to about 1. Okay, so 0 to 1. But that's an estimate, all right? It could be 1.3. I don't know. So that's an estimate, so I'm going to highlight that. And then decreasing after that from, like, say 1 to 4. Okay, so decreasing now from 1 to 4. So I'm going to put that on the decreasing side now. So decreasing from, let's say, 1 to 4. That's from here until the asymptote. But that one part, again, that was an estimate. Okay, and then this last part, this is decreasing. So from 4 to infinity. From 4 to infinity, it's definitely decreasing. Now that's the one interval that I'm not actually guessing on or estimating. So 4 to infinity. So I'll leave that unhighlighted. But the rest of this, I'm fudging it. Okay, again, on the test, we'll have a cleaner one for you. Anyway, there's no symmetry going on here. It's not happening. This is low. This doesn't do that. It's weird. Symmetry, nah, neither. Okay. So we're getting a little bit more advanced, a little more tricky, but I hope we're learning about all the things that can happen. Alright, we have just one more problem to do. So I'm going to end this video here, but we will pick up the next video with number 11.